Okay, so last lecture we were learning the biosynthesis of cholesterol molecule. So in that one we have seen different steps in all the biosynthesis of the cholesterol. So far we have superficial classified this synthesis in 5 different steps. So that all things we have covered actually. Let's take one review. Biosynthesis of mevalonate. Okay, so first step is biosynthesis of mevalonate occurs from acetyl coenzyme A. Next stage, we have to convert the bioavailable ester to the isopreneur units. So as we know, isopreneur units is nothing but the containing C5 carbon atoms. So that one we have synthesized from the mevalonate by loss of carbon dioxide. So next one, condensation of 6 isopreneur units to form squalene. Okay, so we can synthesize squalene from the 6 isopreneur units, and finally we have to convert this squalene to the lanesterol, first parent steroid, and cyclization of squalene to give lanesterol. And once you got lanesterol, you can convert the lanesterol to the cholesterol. Okay, so with all these things, this is schematic presentation of this schematic presentation of the cholesterol synthesis from the acetyl coenzyme A. So if we will go step by step from the acetyl coenzyme A, we have this as acetoacetyl coenzyme A. Then we have to convert all these things, mevalonic acid, then to mevalonate. Okay, and mevalonate we did convert to the isopentenyl 5-pyrophosphate. Okay, C5 C5 unit, IPP unit, which contains carbon number 5. And this isopentenyl 5-pyrophosphate, that's when we can convert to the dimethyl allyl pyrophosphate. Okay, DPP. So isopentenyl pyrophosphate IPP and dimethyl allyl pyrophosphate is DPP. Okay, so this dimethyl allyl pyrophosphate we can convert to the geranyl pyrophosphate. Okay, so geranyl pyrophosphate, this we can convert to the farnesyl pyrophosphate. Okay, so farnesyl pyrophosphate, once we got farnesyl pyrophosphate, which contains C15 carbon atoms. Okay, farnesyl pyrophosphate is nothing but the C15 carbon numbers, and this farnesyl pyrophosphate we are going to convert to the squalene, and then squalene eventually we will convert to the lanesterol. Once we got lanesterol over here, lanesterol we can convert to the cholesterol. So up to last lecture we came over here the synthesis up to biosynthesis of the farnesyl pyrophosphate. Okay, we have seen the steps over here, and now we will go for the next step, how to go for how to convert the IPP to GP, farnesyl pyrophosphate, how to convert this farnesyl pyrophosphate to the squalene. So this is the schematic presentation of mevalonate. Okay, mevalonate we do convert to the IPP, pentenyl diphosphate. Okay, so isopentenyl diphosphate, once you got carbon number which contains carbon number 5, so isopentenyl diphosphate we will convert to the dimethyl allyl diphosphate DPP. And once we convert this IPP to DPP, and we can, if we will combine these together, we can get the geranyl diphosphate, and geranyl diphosphate we can eventually convert to the farnesyl diphosphate. So let's count the number of carbon atoms: 1 2 3 4 5 6 7 8 9 10 11 12 13 15 16. Okay, so one more time we'll go: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so farnesyl diphosphate having is C15 carbon numbers, C15 units, carbon numbers are 15 there, and that one now we are going to use this farnesyl diphosphate. Okay, so we are going to synthesize squalene from the farnesyl PP. Okay, so now we'll go for this. From here we will start, because this part we have covered already. So farnesyl PP to squalene, we'll see now how to synthesize this one. Okay, so as we know, squalene C30 synthesized from the 6 molecules of isopentyl pyrophosphate units, and the reaction sequence from C5, C10, C15, and C30. So this stage is synthetic synthesis of cholesterol starts with the isomerization of isopentenyl pyrophosphate to the dimethyl allyl pyrophosphate. Okay, so we know that IPP we can isomerize to the DPP. Isopentenyl diphosphate is isomerized by shift of double bond only. Okay, so only double bond, position of double bond has been changed in the IPP and DPP, dimethyl diphosphate. So, and then condense with another molecule of isopentenyl diphosphate to form 10 carbon atoms intermediate, that is geranyl diphosphate. So synthesis of squalene, we will see now how to do the synthesis of squalene. So farnesyl pyrophosphate FPP, okay, to squalene. So we are going to convert farnesyl pyrophosphate to squalene. Synthesis of squalene, we will see IPP and DPP condenses to produce a 10 carbon geranyl pyrophosphate GPP. Now, once we got geranyl pyrophosphate, another molecule of IPP condenses with the GPP to form a 15 carbon farnesyl pyrophosphate. So we got here FPP 15 carbon farnesyl pyrophosphate. Okay, once you got farnesyl pyrophosphate, 2 units of this farnesyl pyrophosphate unite and get reduced to produce a 30 carbon squalene. Okay, so we are going to generate, or we are going to biosynthesize this 30 carbon squalene from the farnesyl pyrophosphate. Let's see now how to convert it. So here, yes, again, the same explanation I have given. Further condensation with isopentenyl pyrophosphate forms farnesyl diphosphate, and 2 moles of farnesyl diphosphate condensation gives the squalene. So here 2 moles of farnesyl pyrophosphate C15, number of C15 farnesyl plus in presence of NADPH. Okay, in presence of NADPH, it gives squalene. Squalene structure with C30 carbon atoms. Okay, so in this way we will get our squalene, which has the C30 carbon atoms. So now here condensation of 6 isoprolyl units to form squalene. So now we'll see now first molecule they have taken DPP, dimethyl allyl diphosphate. Okay, 5 carbon atoms are here. Next isopentenyl diphosphate we have taken 5 carbon atoms are here. 1, 2, 3, 4, 5 isopentenyl diphosphate we have taken. So we did condense these 2 molecules to give the geranyl diphosphate C10. Okay, C10 we got here geranyl diphosphate. So once we got geranyl diphosphate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more 10 carbon atoms geranyl diphosphate we got here. Now we will again add 1 isoprolyl unit to this geranyl diphosphate to get C15 farnesyl diphosphate. Okay, so only we have to add 1 more isoprolyl unit to the existing molecule whatever we have in our hand. So in C15 farnesyl diphosphate, okay, in C15 farnesyl diphosphate, we are going to add 1 mole of now we got C15 farnesyl diphosphate from geranyl diphosphate and 1 isoprolyl unit. Now we got C15, and now we are going to condense these 2 moles of farnesyl diphosphate, okay, in presence of NADPH. 2 moles of the farnesyl diphosphate, C15, 2 moles of C15 molecule farnesyl diphosphate to get this squalene C30 molecule. Okay, so we are going to get here C13 squalene molecule. Now we will see now how to convert this squalene to the cholesterol with the help of enzymes.